Good day. On behalf of Joint Industry Project Corrosion Inhibitors, I would like to welcome you to the webinar series Precision in Corrosion Inhibitor Selection Testing for Oil and Gas Applications. Precision is the first right step. The objectives of the webinar are twofold. One, to promote broader awareness across the industry on the need for developing standard test methods with published precision for corrosion inhibitor evaluation and selection. We will also discuss the process of developing standard test methods and the importance of collaboration and coordination in the development of standard test methods. On these two bullets, today we will hear from Sarah as to how AMP gets involved in developing well-recognized standards. Today is the kind of last of this section. From the next webinar onwards, we'll be having panel discussions on how, once the standard test methods have been developed, how they will impact the industry best practices. So basically, the major objective of this webinar series is to promote broader awareness across the industry on the importance of precision. Obviously, the second aspect is to promote the joint industry project on how to evaluate the efficacy of corrosion inhibitors used in the oil and gas industry. Again, the driver and the motivation for this JAP as well as the webinar series is to ensure that the corrosion inhibitor evaluation is also quantitative, similar to other corrosion control strategies such as materials, coatings, and cathodic protection. So right now, the qualification or selection of corrosion inhibitors are based on qualitative considerations. We are going to make it quantitative to the extent possible. Standard test methods don't get developed on their own. It takes a long time. For example, cathodic protection, the iconic NACE first standard, RP0169, was originally published in 1969, but the industry and NACE worked for more than 20 years before the first publication was made. Similarly, on coatings, ASTM took almost 30 years before they published 13 standards, ASTM standards in 1970s. And then another iconic standard published by NACE on material selection for sour service, MRO 0175 or ISO 1556 was published in 1975. But that work also originated in Calgary. The industry worked on it for almost quarter of the years. But the inhibitor selection took even longer time. The first publication happened in 2009, but we still need more standards with precision statements. And I believe that, or the JAP believes that this is the pivot moment for that. So with that, today's webinar is to discuss on how we can reduce the cost of corrosion inhibitor testing by 1/3. I will give a brief introduction on that one, and then Sarah will present on behalf of AMP. So let us review as to how we are evaluating corrosion inhibitors currently. Because the current test procedures are not standardized, they have a large amount of variability. So non-standard test results vary considerably, and between one lab to another lab, it cannot be verified. Because at this stage, corrosion inhibitor evaluation is qualitative. As a consequence, currently we do three steps. First, the corrosion inhibitor supplier test and approve their products. Only when they are convinced that their product is good, they'll bring it to the market. And then the end user test on their own. Sometimes the test results agree with the supplier, sometimes they don't. Many times they don't. And then they go to a common ground. They will test it in a third-party laboratory. We have got well-established third-party laboratories around the world. But right now, to qualify a corrosion inhibitor, we do three steps, three tests. Sometimes same test, sometimes different tests. And also, there is no easy way to evaluate the reliability of testing laboratories, whether it is third party or the supplier or the user. For example, if you are going to test a material for implant, medical implant, that lab must qualify itself using ASTM G5. That has been coded in the medical association. So no lab is allowed to test anything for implant unless the lab qualifies itself. That rigorous process is not carried out for the corrosion inhibitor evaluation because we are not standardized the test methods. That's what we are going to do in our JAP. Once the standard test methods are developed, it will reduce the evaluation into a single step because everybody will be following the same steps. Everybody is expected to produce the same results to start off with. That way, the user can evaluate and compare and determine dosage requirements of many chemicals. Suppliers can easily accelerate development and marketing new chemicals. Third-party laboratories can demonstrate they have the qualification, they have the quality assurance by verifying the results under standard conditions. So that will help them a marketing tool to service both users and suppliers. As a result, the current three-step process will become one-step process if we establish good standard test methods. So that is the premises with which we are running this joint industry project towards that goal. Again, I would like to thank the sponsors. In fact, two other sponsors have unofficially confirmed. Hopefully, I'll be able to give their names out at the next webinar. Quickly, the main objectives of the JAP are to collect and summarize the existing best practices, which was done in phase 1. In phase 2, we consolidated those information into guidelines representing industry best practices. We have got 23 reports on each one of the 23 applications. Phase 3, which is the focus of this phase of this year, which was started in December 2nd, 2025. The main focus is to establish standard test methods for the 8 laboratory methodologies that have been identified. When we say standard test methods, these standard test methods will publish the precision. What is the variation if somebody carries out the test? So the JAP will focus on precision based on repeatability, one person, and we'll also extend precision based on reproducibility through either ASTM or AMP after the JAP is completed. And in the previous webinars, we went through the 8 methodologies, the 6 methodologies rather, and today's webinar, we will focus as to how we are going to standardize the electrochemical quartz crystal microbalance for 3 reasons. One, to determine the inhibitor film thickness, inhibitor film thickness, film persistency, that is to address the batch inhibitor frequency, as well as potentially for the top of the line corrosion inhibition evaluation. In 2007, I had the opportunity to listen to one of the best presentations, one of the very good presentations made by Joe Blackburn. And that presentation is still available with me. If you're interested, I can share. And Joe, what he did was he collected from the industry the various rules of thumb that is being used as to how much of corrosion inhibitors are needed in the field. Again, there are some 16 criteria, including 1 pin or 1 quart per mmCq of gas, 25 to 50 ppm, lab test 1 gram per 1000 feet, and 3 gallons per diameter inch per mile. And Mr. Blackburn went through as to how these rules of thumb came into being, and it's being extensively used. And what he found was that in 1940s, there was a very famous scientist, Dr. David Hagerman, who is considered as the guru of corrosion inhibitor. And he did the experiments in 1940s and 50s in which he correlated mass transfer coefficient, that is the rate at which the chemicals are passing through a film as a function of film thickness. As the film thickness increases, the diffusion rate decreases. As a consequence, corrosion rate decreases. And what Dr. Ackerman's lab found was when you have a 3 mil thick inhibitor film on the surface, you will reduce the corrosion rate to a very small amount. And all these criteria, 16 criteria that are being used widely around the world, are all based on this work that was done in 1940s and 1950s. So moving forward, can we quantify that 3 mils or 5 mils using the quartz crystal microbalance? Again, I'm not going to go into the details, but basically the quartz crystal microbalance, it monitors the frequency and relates to the mass. It measures the frequency. From the frequency, it gives the mass. But the beauty of this microbalance is that it can measure the mass change in nanogram. So that is quartz crystal microbalance. If you add the electrode, that becomes electrochemical quartz crystal microbalance, EQCM. The quartz crystal can be used as an electrode, and hence it is known as electrochemical quartz crystal microbalance. The EQCM measures two properties. From the frequency change, we can determine the mass change, and from the electrochemical change, we can determine the corrosion rate. So basically, one surface, two measurements. One measures the mass loss, two measures the electrochemical activities. So basically, this is a crystal on which iron is deposited, on which the inhibitor film is formed, and the inhibitor film's behavior is followed using electrochemical techniques. Again, this work was published long ago. I'll quickly summarize one data. In one experiment, the iron deposited on the quartz crystal was exposed to a batch inhibitor for 9 seconds. 9 seconds, 15 seconds, 23 seconds, and 45 seconds. When it exposed to 9 seconds, you can see the mass increases, and at around 300 minutes, the inhibitor film completely dissolved, and you can also see the potential varied. So this point is where the inhibitor was effective. When the contact time of the batch inhibitor was only 9 seconds, the inhibitor film was there only for 300 seconds, 300 minutes. But when the contact time increased to 45 seconds, the inhibitor film, first of all, it is very thick, 800 nanogram, and it lasted for almost 900, 9,000 minutes. So that accuracy can be established by EQCM, and this work was published a long time ago. So the objective of the GIP is to standardize the cost crystal microbalance for batch inhibitor frequency evaluation, as well as to establish what is the minimum film thickness of corrosion inhibitors that is required. The preliminary study indicated that we need at least 2 microgram per square centimeter of inhibitor film to be present for it to be protective. Again, this was preliminary work. In our JAP, we are going to establish and standardize how to use quartz crystal microbalance for batch inhibitor frequency establishment, as well as to establish the inhibitor film thickness, so that the 3 mil thickness that we have been using in the industry, we can provide some quantitative data. So that is the objective of the JIP. But as I said, the focus of the JIP is to establish standardization. To establish standards, there is no better organization other than AMP and ASTM. And today we are going to hear from Sarah Althoff on how AMP develops standards and the processes they follow through, as well as the currently existing corrosion inhibitors evaluation standard. Sarah is a senior technical manager at AMP, where she leads the technical engagement team supporting technical communities, standards development, research initiatives, addressing global challenges in corrosion protection and protective coatings. Sarah has got more than 25 years of experience in material protection. Before joining AMP, she served as a national director for corrosion protection and laboratory president of a civil engineering firm, collaborating with multidisciplinary teams to implement effective protective coatings strategies. So again, we are going to hear from the horse's mouth on the importance of collaboration. With that, I will leave the floor for Sarah to make her presentation. Sarah.
Screen?
Yes, Sarah, thank you.
Great. So again, thank you for inviting us as AMP to give an explanation of our standards development program. So just a quick overview of AMP. I'm sure that many of you are already very familiar with AMP. So AMP, the Association for Materials Performance and Protection, was formed in 2021 by a merger of NACE International and the Society for Protective Coatings. So AMP is the world's largest leading organization focused on protection of assets and performance of materials. We have under our organization, at the time of the merger, more than 400 consensus standards, guides, and technical reports. So all of those standardized documents that came from the NACE International and SSPC together to form our portfolio of documents. So AMP is a global organization. We have 180 chapters around the world and have recently grown to over 40,000 members globally and almost 1,000 corporate members. So our standards program specifically, we have currently 467 active documents. Those documents are developed within 27 standards committees. We currently have 400 active projects and over 2,500 volunteers who participate on our standards committees. In addition to the standards committees that develop documents, we have 49 technical communities that are kind of discussion groups to look at industry gaps and needs on the various topics that fall under AMP's purview. Today, I'm going to talk in detail about how our standards program works. I know many of you are active probably in our standards program, but I still wanted to go through the details on how AMP develops standards. So our standards program is based on the World Trade Organization's standards principles. So those principles are based around transparency, openness, impartiality, and consensus development to develop effective and relevant standards that have coherence and go through a strict development process. So the way our program is organized, the AMP Board of Directors governs everything that happens in the association. This is member-based board of directors. Then we have our standards program committee that again are volunteer members of the AMP Association who govern the operations of our standards program. Then the standards program is broken into 27 standards committees. Those committees are led by volunteers, and then to participate on those standards committees, anyone can participate. So this is where we don't require AMP membership at this level in our program. So the standards program committee again reports to the AMP board, and they provide the strategic direction for our program. They ensure that the development process is effective and efficient. They maintain a plan, a strategic plan for how they would like to see the direction of new business development. And they also provide recommendations for improving the operations of the standards program. So our development process begins with an idea for a new standard or document. And from there, the committee chairs of our individual standards committees review those requests to begin a new project, and the committee can approve those projects. Now, if we're going to create a joint project with another standards development organization, maybe with ASTM, then those joint standards projects need to be approved by the standards program committee before they begin the process. So once a project gains approval, a document project manager begins to develop the draft document. So the document project manager can work with a team of people or mainly on their own to make that initial draft. That initial draft is then sent out to the full standards committee for a ballot, and then goes through a cycle there where the committee comments and sends that draft back to the document project manager and the project team until a consensus is achieved. So for AMP to consider a consensus to be achieved for approval of a document, at least 50% of the voting members of the standards committee have to vote, and of those voters, we have to have at least 75% that vote affirmative. And then the third hurdle that has to happen for a document to be approved is anyone who comments on the document draft. All of those comments have to be properly adjudicated before that ballot can be confirmed and consensus achieved for approval. And then the final step is the standards program committee reviews the process to make sure that all of those documents comments were properly adjudicated, that all of the ballots achieved the proper voting statistics, and that the full process was completed appropriately before that document goes on for publication. So in order to create a joint document in AMP's program, the process moves exactly the same as an internal AMP document, with the exception of an upfront approval by the Standards Program Committee. So the Standards Program Committee makes those upfront approvals of joint projects. So that would be a project where an AMP standard is going to be submitted for adoption and publication to another standards developing organization, or where AMP is going to adopt another standards organization's document that they have created through their process, or in the circumstance where we're going to jointly develop a standard. So AMP has agreements with a few different standards developing organizations. ASTM is one, IEEE is another one, and there are a handful of others where we do work jointly to create those documents. But when we start a new project for those joint documents, we do need to get approval by the current standards program committee for that to move forward. And then that approval needs to include endorsements from 5 user organizations explaining why it's important to industry to develop that joint document. And then the SPC will consider approval of that joint industry project. So AMP has a few different types of documents, and we'll go into the specifics on what makes each type of these documents different from the others. So a standard practice, as far as AMP defines SPs, have requirements and recommendations for a material or system. So that could include selection, design, installation, operation, any of those details. And they provide detailed descriptions of the requirements with very prescriptive language, so shall and must type statements. A test method is specifically for ascertaining the characteristics of a material and defines those specific steps to carry out a test method. AMP test methods do not include pass-fail criteria for the material, the design, the operations, or whatever parameters are evaluated by that test method. Just lays out the steps to conduct the testing. AMP also publishes materials requirements. Our most well-known standard is MR 0175. I think many of you are familiar with that, and that is a materials requirements. So MRs define the required or recommended characteristics of a material. They can include requirements for chemical composition, various different types of properties of that material, and other aspects of the material's manufacture and of its use. AMP also publishes some specialty documents, guides, and technical reports. So guides give a lot of information about how different procedures can be compared, how materials and technology can be compared for selection. They do not contain any prescriptive language. So they don't say you shall or must do anything. They just give some guidance as to how to make good comparisons of your options and some recommendations on best practice. Our technical reports document procedures, practices, and technologies that maybe are not quite ready for standardization. They often include compilations of data, some historical information, common practices, and most importantly, contain bibliographies where additional information can be referenced. So technical reports do not outline specific procedures or test methods. They just give kind of the state of the art on where industry stands at the time that technical report is written. So in order to create the highest quality documents, we need participation from across a broad swath of interested stakeholders in any project that we're working on. So we encourage open participation. So anyone who has an interest in the topic that is covered by the particular document project is heavily encouraged to participate. We do not require AMP membership, and to join one of our standards committees, you can go to our website, amp.org, and search on standards under the heading standards and technical. If you go to About Standards, this page launches, and at the bottom of the page, you can click the button to join our committee. Simple as that. So we have different classes of membership on our committees. We have observers. When you first join a committee, you'll join as an observer. You can request voting membership of the committee. Our committees maintain a balance of voting members from different classes of stakeholders. So users, producers, and general interest are our classifications of stakeholders. And our voting members maintain a balance between those different types of stakeholders. Observers of our committees also have an opportunity to comment on the drafts of our ballots, and they can participate in these standards committee meetings, and they can participate on the project teams. They just don't get an affirmative or negative vote on the ballot. Any comments received from our observers on our committees are adjudicated the same way as comments coming from voting members. So it's an important thing to remember as far as getting the broad input to produce the best quality documents is those observer comments are considered and incorporated into that final draft for approval. So we have many standards committees. We have 27 to be exact. And I'm just going to scroll through these to give you kind of a flavor of the breadth of our standards program. So we cover a broad range of topics and different aspects of the materials protection industry. So these committees are focused around specific topics so that the ballot pool is divided into groups of people that have expertise on the documents that are produced by those committees. So now I want to switch gears a little bit and talk about some of the documents that we've produced that are specific to inhibitors, specifically of interest to this project. So AMP has produced over the years technical reports. So there's a couple that are based on laboratory evaluations of inhibitors. You can see in the list there, NACE TR 31215 and NACE TR 1D182. So these are technical reports that discuss testing of inhibitors. We do have 3 active test methods for inhibitors. And then we have 1 currently active standards practice on inhibitors and 1 material requirements for inhibitors. So to give you an overview of some of the things that are happening currently in the AMP standards program, here's a list of recently published documents. These are the things that were published in 2025. Just give a little time to see the list here.
Sarah, you can take more time. We still have time. Go ahead.
Gotcha. And these are some of the active new document projects that are happening right now in our various standards. So this is just a selection of some of the projects that we have that are working their way through committee right now. Some of the most recently started projects. And the last thing I wanted to cover was where to gain access to the AMP standards. So recently we launched AMP Knowledge Hub. You can access Knowledge Hub from the main page of the AMP website or using the QR code that's shown on the screen. AMP Knowledge Hub is one portal that gives you access to all of AMP's standards, magazines, technical content, books, journal articles, all in one place. So to access AMP Knowledge Hub from the main page of the website, you'll see this Knowledge Hub right by the search bar. You click there, and that will launch the Knowledge Hub portal. So that's the end of my presentation. I'd be happy to take any questions.